What would be the radius? They tell us that the diameter is 20. So we got 10. So we got pi times 10 squared times 150. Go ahead and figure it out in terms of pi. What is the volume in terms of pi?
Wait, we do, oh, never mind.
100 pi times 150, so that would be 15,000. Yeah, 1,000, right? Pi. Okay, well, that's the cylinder. Now we have to do the sphere, but it's half of a sphere, so let's start with the sphere formula. What's the volume of a sphere? Again, try not to look at your notes. Test yourself. Okay, 4/3. That's good. 4/3 what? No. There's a pi in there, yep. Pi r. Not, yeah, cubed. There you go. 4/3 pi r cubed. Okay, so let's go for it. And then we'll, since we only need a hemisphere, once we get our answer, we're gonna have to divide it by 2. But let's go ahead and plug everything in. So that's 4/3 pi times 10 to the power of 3. 10 to the power of 3 is 1,000. Take that number, multiply it times 4, and then divide it by 3. What do we get? Actually, and it looks like all of these are fractions. So let's keep it as a fraction. So what do we get as a fraction? That's a decimal. Keep it in fraction form. This is 4/3 times 1,000. So that's going to be 4,000 over 3 pi. 4,000 over 3. But now I need half of that. So 1/2 of the volume wouldn't be 4,000 over 3. Hi. It wouldn't be 4,000 over 3. What would it be? 2,000 over 3. Okay. So I have the volume of the hemisphere. I have the volume of the cylinder. What should I do to them to get our final answer? We're going to add them together. But in order to add them, look at all our answer choices are over 3. So I need a common denominator. How do I rewrite 15,000 to make it over 3? What would that be? Okay, so then 45,000 plus 2,000. Where's my answer? 4,700. Good. Answer choice B. All right, so with this type of question, you might see it, right? Where you have to find the volume of, it's like this is called a composite figure. Let me write that down. Composite figure, because what's happening is you have 2 different solids, you can find their volumes separately and then add them together to find your total volume. Are there any questions on that? Okay. All right. So let's go ahead and get started. Like I said, we're doing one more thing today, one more new topic. And then from there, we're just going to do a couple review questions until we get to the last 15 minutes, and then I'll let you guys take your quiz. Well, in order to start our new topic, I'm also going to share the same document as yesterday so that you can take a look at the links on GeoGebra. So let me get that in the chat. So what we're going to be doing, and I'll send you the link in a second so you can see it for yourself, is we're going to be rotating this triangle around and around and around using that leg as the axis of rotation. So in other words, this line right here, that's the axis of rotation. And this triangle is going to be spinning around and around and around and around. And I want you guys to take a look at what that's going to look like. Go ahead and click on, we're on number 7 now. So look at link number 7 and take about a minute. All right, take about 10 more seconds. This is link number 7. And I only see 3 people on the Google Doc, so I can tell that there's a few students who have not clicked on it yet. There's an anonymous lemur, anonymous chinchilla, anonymous dragon. Oh, okay, we got an anonymous hamster now. That's good. All right, and start heading back. All right, so back on the Zoom screen, here we are. I have a right triangle, and who can tell me what happens when you spin that right triangle and rotate it around that axis? What do you get? It becomes a cone. So T is the amount, it's not super important what T is, but T is the amount of radians actually. And remember that a full circle is 2 pi radians. So what's happening is we're going to spin this around and around and around and around. And when you do so, you end up creating a cone. And there's my cone. The shader in. Okay, so we end up getting a cone. So when you rotate a right triangle about is the same as saying it's around. So when you rotate a right triangle about one of its legs, you obtain a cone. You obtain a cone, and that cone is going to have a radius of what? Using this triangle, what would be the radius of the cone? If this is A, B, and C, what's the radius? Good, Jalen. Radius is BC, and what would be the height of the cone? Give me, I want a full line segment. So not just A, but from A to where? A, B, good. Good, this is the height, and that's the radius. All right, any questions on rotating a right triangle? Pretty easy, right? Now, why does it have to be a right triangle? What would happen if I tried to do the same thing with an acute triangle? So something that looks like this. Where this is less than 90 degrees. What would happen? The height would be messed up. Think about it, try to visualize it. It would be a spiky cone. Yeah, so it wouldn't be a cone, it would end up being something more like, let's see if I can draw this. Something like this, which kind of, to me, that looks kind of like a top, like, you know, those top, yeah. There you go. We're on the same page, Tyrone. Yeah, it would be kind of like a top. So it would not give you a cone, it would give you something else. So it's got to be a right triangle. Questions on this one? Okay. No, not a shirt, a top. Like when you're a kid and you play with the spinny things, or did you guys already have too many video games by the time you were? It's like one of these things and it goes around and around.
They used to give them in Chuck E. Cheese. I used to get some, and then I would spend them, but then they stopped giving them. So
Beyblades are like an extreme type of top. Like the basic version, you just spin it with your hand, but a Beyblade, like you gotta like shoot it off. Okay, let's check this one out. So now, before you click the link, see if you can think of in your head what's gonna happen when you rotate a rectangle around and around. What's gonna happen? What are some predictions? Jalen says a cylinder. Tyrone disagrees. It would not be a cylinder, but it would be similar to a cylinder. Okay. But more spiky. Okay. So go ahead and click on the link now and let's find out for ourselves. And when you click on the link, this one's kind of cool because you can change the length of the rectangle. So it starts off almost like a square and you can actually make it taller if you want to. Uh-oh, what happened, Tyrone? It's a cylinder. Yep. So take a couple more minutes, guys. I want you guys to really play around with it. You do get kind of a cheese block if you only go like a quarter of the way. That's fun. Yeah, no, it's actually British people too, Perla. The word mate. All right, so go ahead and come back over. And what we just found is that when you spin this in a full circle, what happens, Tyrone? We get a cylinder. We sure do. All right, so there's my cylinder. Let me fill it in. All right, so I'm going to write it out again. And the reason I'm writing it out is because this is the type of way, this is how you might see it in a word problem. And you guys know that they love to give you word problems without any pictures at all. So it's important to see what that looks like. So when you rotate a rectangle about one of its sides, you obtain a cylinder. Now, on my cylinder, what is the radius? AD as well as BC, yeah. Both of them work because they're congruent. AD and BC are congruent. And what's the height? BA, good. Or BC, or I mean CD, since again, those are congruent. Okay, so there we go. That's our cylinder, and we get that by rotating a rectangle. Do we have any questions on that one? All right, we just have one more, and that's it. And then we'll do our review. What happens when you rotate a semicircle about its diameter? Good. Yeah, I didn't even put a link for this one because this one should be pretty easy, pretty simple to see. So when you rotate a semicircle about its diameter, we're going to end up with a sphere. Oh, that is bad. Let me do that better. It's so hard. If you've ever tried this, it's really hard to draw a circle from half of a circle. So I overshot this a little bit, but there we go. There's our sphere. Okay, so who can tell me using words? Does anyone want to give it a try? What would I write down as my description? Try to think about the way that they phrase things. Yeah, but so we get a sphere from doing what? It's okay. Anyone else want to give it a try? By rotating? Rotating what? A semicircle. Oops, that's not the word. Semicircle. Keep going. Good. So we would use the word about its diameter. Okay. You will obtain, that's the fancy word, you will obtain a sphere. Now, here's the question. This one's not labeled, but let's say the diameter of the sphere will be the same as the diameter of the semicircle. That's the same diameter. So any questions on rotating these three figures? A right triangle, a rectangle, and a semicircle. Any questions? Awesome. So with these questions, kind of similar to yesterday, we can learn the basic ones, and then they might give you a new rotation that you've never seen before. But the most important thing is to try to visualize it yourself. So if you ever see a new one that we didn't cover, you have to try to visualize it yourself and then try to predict what's going to come out. So let's try a word problem, no pictures. This is why we have to really read carefully. Who would like to read for us the first one? Not Tyrone? Oh my goodness. What is going on? Anyone else? Your esophagus hurts. Okay. Anyone? Really?
Well, then tell somebody.
Okay, how about you, Jalen?
Are you serious, man? All right, come on. All right. An isosceles triangle is placed on a coordinate grid of its legs and on an x-axis, and this other one on the y-axis. What describes the sphere created when the triangle is rotated about the x-axis?
Oh my goodness. Okay.
Yes, I know my accent's very good, isn't it?
It's a bit Cockney, I think. Okay, what do you guys think? So I'm not gonna draw it yet. But from what you read, actually, let's do a poll. Why don't we do a poll? Go ahead. All right, 10 more seconds. Three, two, one. Okay. So everybody voted, I believe, it looks like. Oh no, I'm missing one. But I don't know, do you guys want me to share or wait until after I explain it? Now? Okay. Here we are. Here we are. So it looks like I have 3 students who were not paying attention to a word I said. Uh-oh. Okay, let's take a look. So an isosceles right triangle is placed on a coordinate grid. Okay, here's a coordinate grid. One of its legs is on the x-axis. That's one leg right here. The other one's on the y-axis. Okay. And I know it's a right triangle, so here's the third leg. And we're going to spin it, rotate it about the x-axis. So when I spin it, am I spinning it to the left or am I spinning it down? If I'm rotating it about the x-axis. Okay, down. So this guy's going to go down and then back up. And it's just going to go around and around and around and around and around. And when you do that, you're going to end up with this shape. What is this? What is this? I only have one person participating. What's going on, y'all? That's a cone. That's a cone. Even though it's sideways, it's still a cone. You guys, how in the world am I going to get a pyramid which has edges? How in the world am I going to get a pyramid if I'm spinning around and around? That's going to make a circular shape. There's no way to get edges, okay, from doing this. So it is going to be a cone. And that is simply something that we just wrote down. So everybody who got that wrong, y'all were not paying attention to a word I said, and that's pretty upsetting. So let's try to fix that going forward. Because when I teach something, I expect you to have it in your notebook, in front of you, written down. We're in school, we're taking notes. We don't just memorize, like that's just not how this works. You can't just try and remember everything in your head without taking any notes. You have to be taking notes. Let's try another one. An equilateral triangle is continuously rotated around one of its medians. We'll talk about that in a moment. But I want you guys to try it first. Try to visualize it because this is different. Oh, sorry. This is a different situation than the first one that we did. So read it carefully. Try to visualize it. You can draw it out if that helps you. Go ahead. Okay, again, try to visualize it. Try to, if you want to draw it out, try drawing it out. Take 10 more seconds. All right, 3, 2, and 1. All right. Okay, that's a little bit better. Most people chose A, and that is correct. Again, so this time it's not a right triangle. This time I have an equilateral triangle, and it's being rotated around one of its medians. So the word median, we've seen it before, but we haven't really gone over it. But what does the median sound like? Where does it sound like it's located? Yeah, down the middle. That's exactly what it is. So what's happening is you have this triangle, it's equilateral. So it probably looks something like this. And it's being rotated about the middle. Okay, so here's the middle. This guy's gonna go around and around and around. Around and around and around, and that's going to create a cone. Again, you can't get a pyramid or a prism because those have edges. Pyramids have edges, prisms have edges. And in this case, you're creating a circle, so there's not going to be any edges. So it's going to be a cone, not a pyramid. And a sphere, the only way to make a sphere is out of a circle. So those of you who keep choosing those options, I hope we're learning from our mistakes, because again, the only way to get a sphere is from a circle, and pyramids, they're not going to happen if you're rotating. Any questions on this one? Okay. All right, here's another. We got the poll going. Okay, go ahead. A student has a rectangular postcard which he folds in half lengthwise. Next, he rotates it continuously about the folded edge. Which three-dimensional object below is generated by his rotation? All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So if you've continued to choose pyramid, I'm going to ask you to let me know in the chat what your question is. Like what's the confusion? How can I be clearer as a teacher? How many times can I say the same exact thing? And if you're just choosing a random answer because you don't even want to try and you're just guessing, then, why are you even here? Why bother coming to class? Why bother? Don't waste my time. Don't waste my time. If you're just going to come to class, pick random answers because you just want to make sure you get participation, and then walk out of here and not learn a single thing. If you're not being active in your learning while you're in my class, then you are wasting your time and you're wasting my time. Because I would much rather be in a class with students who want to be here and who want to learn than with students who just continue making the same mistakes. Guys, it was 3 problems in a row where I had the same, I don't know if it's the same students, but I had students choosing the same answer, even though I explained it twice already. You still keep choosing the same wrong answer. And that usually when people pick wrong answers, I'm very lenient. I don't care if you get it wrong because we're learning. But when I've gone over it twice already and then you still make the same mistake and you still pick the same wrong answer, that's when I start getting annoyed, because that tells me that you're just not listening to me. And there's a difference between not understanding something and ignoring your teacher. One of them, I understand. The other, I'm going to get pissed off about it. That's disrespectful. And I don't want to be in a bad mood on a Friday of all days. But if I'm going to have to be in a bad mood in order to get people to actually pay attention to me, then that's just what it's going to have to be. But you guys know that I don't like that. So by continuing to do so, now you're putting me in a situation that I don't want to be in. And that sucks. That really sucks. And it impacts not just my mood, but it's going to now impact everyone else's mood who's actually here to learn. I have a postcard. Okay, it's probably going to be like a rectangle shape. Let me make that better. That's more of a square. Okay, so here's my rectangle. And he folds it in half lengthwise, so the long side. Okay, and then he's going to rotate it continuously about the folded edge. So we're spinning around and around this way. And that's going to give us our cylinder. Any questions on this one? Okay. I believe I have, yes, I have two more. Honestly, I don't even want to do a poll because I don't want to be put into a more of a bad mood. So instead of putting it in the poll, just go ahead and send me your answers in the chat privately. Which of the following is the best description for the resulting three-dimensional figure if a right triangle is rotated about the line containing its hypotenuse? And for this one, make sure you read carefully. I highly recommend that you draw this one out because there's a question that, or there's an answer choice that you're probably leaning towards, but I want you guys to try drawing it out and see if it matches what you think it is. Okay, try it out, draw it out, and I want to see your answers in 15 more seconds. All right. Yeah, this one is a little bit more challenging. Those of you who sent me an answer and I told you that it was not correct, see if you can get it right. Send me your backup option. If it's not that answer, what do you think it might be? Tyrone, Perla, Jalen, try one. Just give me a guess. You got it? Send it privately just in case. There we go. You got it. Okay. Yeah, so this one's a little challenging because what's happening is they're rotating it about the hypotenuse, not about the leg. So let me draw it out. So basically we have a right triangle, but this time I'm going to rotate it along this thing. Okay. So what happens is it goes this way. Daniel, you got it. Yeah, everybody got it in the end. Good job. See, it takes a little bit of thought in this case. So it goes this way. And so what happens is you end up with this type of shape, kind of like the one we saw before, the one that kind of looks like a top. But this shape is really, what you really have is two cones. You have one up here, and then you have one facing the opposite direction. So here's one cone, and then the other one's on the top. So see what I said before? Like I showed you guys the basic ones. Well, sometimes you're going to get slightly more challenging questions like this one, and the best thing to do is to draw it out and then try to visualize it. So we end up with answer choice C. Any questions on this one? It was a little bit more challenging. You had to reread it. Yeah. Especially if it's a word problem, you definitely want to read it and visualize it. Some of you guys are good at seeing it in your head. Some of you guys prefer to have it on paper and draw it out. So whichever way works best for you, that's what you want to do. Okay. All right. I think this is it for, yes. Yeah, this is it for rotations. So go ahead and do this last one. Send me your answer in the chat again. If the rectangle is continuously rotated about side W, what do you end up getting? Good. Yeah, this one's a lot easier, isn't it? A little bit easier. So for this one, even though it's going to be rotated about the short side of it, okay, it's still, when we kind of duplicate this on the other side, oops, it's still going to be kind of like a really wide cylinder. Just really, really wide. You think of cheese, like a block of cheese. That works too. Whatever works for you, works for me. So either way, no matter how you do it, with a rectangular prism, you're always going to end up getting a cylinder. Any final questions on rotations? Okay, cool. So from here on out, I have some review problems that are about everything we've talked about this week. So we have volume, we have rotations, and we have cross sections. So what I want to do is I actually want to share these problems. It's just, I think it's only like 12 problems. It's only 10 problems actually, so it's not that many. And we have, let's see, we have about 45 minutes-ish. So let's spend half an hour on the problems and including the time that we go over them. And then afterwards, you guys will take your quiz. So what I'm going to do is I'm going to share this PowerPoint with you guys on, I'll send you the link. We're on slide number 10. Okay, so when you open it, go to slide number 10. You write that down. And then you guys are going to spend about 20 minutes completely on your own. That should be plenty of time. I think most of you will finish with that amount of time. Then we'll go over the answers. I'll help you guys if there were any really challenging ones, and then you guys will take your quiz. So go ahead, click on that link. Go to slide number 10 and get started on the practice problems. And I'll be here in case people have questions and we can go over things together. Oh yeah, TBT to that. Thank God that's over. So I'm going to set my timer right now for half an hour. Actually, maybe like 25 minutes because I don't want to spend too much on this. Yeah, I want you guys to have as much time as you can for your quiz. All right, go ahead. And you can skip around. You don't have to do them in order. So if you want to do a couple from the top, a couple from the bottom, go for it. Ooh, and then for anyone, because I know Janelle's is going to be watching this on YouTube. Janelle's, here's what I'm going to do. I'm going to go to each slide and you can pause the video and work on each problem. And then at the end, when I go over the answers, I'll record it again. So here's slide number 10. You can pause the video. Number 11, you can pause the video here. Number 12, 13, 14, 15, 16, 17, 18, 19, and 20. Cool. Okay. All right. I'm going to go through, just give you the answers. And then if there's like one or two that you guys want me to go over, we'll do that. And then you guys can take your quiz. So slide number 10, answer B, answer choice B. Questions on that one? Okay. I'm going to move quick. So if you have questions, ask them quickly. All right. For answer 11 or slide 11, D. Questions on this one? Yes. How did I get that? Okay. You got C? Let me double check my math. Hold on. Oh, it is C. I'm sorry. I wrote down the right number and then I wrote down the wrong letter. It is C. My bad. Okay, we're good. D is what you get if you didn't divide it by 3. So you have to remember it's 1/3 base times height. Next up, this one's slide number 12. This should be A. Questions on this one? Okay. 13, I got C. Answer choice C. Questions? No? All right, number 14, I got answer choice C. So this one was a little bit challenging. Does anyone want me to go over this one? Yeah? Okay, this is the diameter, so just be careful. The diameter is 9.5. So the basketball volume was 143 pi. And then the tennis ball volume was 2.6 pi. And then you have to figure out how much larger is the basketball. So you're basically looking for what do you multiply by to get 143? So you divide 143 divided by 2.6 gives you 55. Okay, so it's kind of like finding the what's it called? The growth rate, not growth rate, when you're dilating, the constant, the factor. That's what you're trying to do. Okay, so any questions on this one? Yeah, scale factor. Sorry, I'm thinking about algebra right now.
How did you forget and you taught us that?
I teach 2 classes. There's a lot of stuff I have to have in my little brain. Okay, so any other questions on this one? Okay. This one was number 15. I got B. So this one was definitely another challenging one. You had to find the volume of the prism. The volume of the whole prism was 96. Then there's like a cylinder basically inside the prism. Think of it like it's in here and it goes out the other side. So you have to find the volume of that. And that was 18.84. So then you have to subtract because you're taking that part out. So it's 96 minus 18.84, and that gives you about 77. So does that make sense? Did anyone have any trouble or questions with that? All right, cool. Moving right along. I think the rest of these are pretty easy. So With this one, they have the same height and the same radius, so the volumes will be the same. Whose principle is that? What's that called?
The Italian man principle.
What's his name? Almost capillary, Cavalieri. I think there's two L's. Cavalieri, yeah. Cavalieri's principle. All right. This one was B. And Tyrone, I don't know, but it might be. The name, yeah, it might come up, so you got to be prepared. For this one, it's B. Does anyone have questions on this one? You got kind of like a circle in the middle because it's spaced a little bit farther away from the axis. All right, here we got a cylinder. No, sorry, a cone. I'm sorry, a cone. Get a cone. And then finally, no, two more. This one is an ellipse. So when you cut this, you end up with this shape in here. And that shape, remember, it's not a circle because it's angled. So it's not a circle, it's an ellipse. And that one we went over yesterday, so you have it somewhere in your notes. And then finally, this one was rectangle. It's perpendicular to its base. So if I have a cylinder and I slice it perpendicular, I'm going to end up with a rectangle in here. So we got a rectangle. All right, that's all of them. Now, I feel bad because I feel like I rushed that a little bit. So anything you don't finish on the quiz, I promise the quiz is short. It's only 4 problems. 2 of them are pretty easy. 2 of them you have to do some math. Anything you don't finish now, midnight tonight, don't forget once you get home to just pop in and get it done real quick. And then you'll be done for the weekend. So let me go ahead and post it right now on Teams. Give me just a moment. It always takes a second to load. Any questions before I release it? All right, cool. Okay, save. It's going to be due tonight at midnight. I'll give you guys a reminder on Remind later. Okay. It should be posting in the next couple seconds. There you go. It's up. All right, good luck, guys. Go ahead and go to it now. I know you only have 5 minutes now, but you'll be surprised. You probably will be able to do most of it in those 5 minutes.